Okay, so welcome to week 4. This time I think we're just gonna go over types and pattern matching in F sharp. Um, so I guess you guys are familiar with generally what a type is. It's just a way to constrain data in a sense. So you know that you're working with, like when you write your expressions, that they work in a statically typed language. You know that expression is gonna, um, you know that the range of the input in that of that data is applicable for that expression. So we'll start with uh, records. So I think if you we look at a record. That up. Why is this the F sharp? Ah, there we go. That's right. So the record is essentially a collection of heterogeneous types. So heterogeneous just means different. So for example, if I call this person, then I'd have an age, integer, and I could represent their I think the standard is just these capitals. Age is an integer. Email could be represented as a string. So that's and you probably want the name as well as a string. And then if I want to use something like this, okay, so say this person is I don't know, let's say some person 1. I can say I can define this person as age equal 22. Email let's say the name's Claire and the name is Claire. So going on there. I don't think this notebook's working correctly. Sorry, yeah, probably a spot. It's not finding something. Something's not right with the notebook.
Are you able to reload it?
Maybe that's what it is. Let's try that.
'Cause I always have to. I use Jupyter Notebook for Python. I always have to restart the kernel to
Okay,
get it to work sometimes.
okay. Yeah, okay. That was it. For some reason it didn't start correctly. I'm not sure why, but that should work. So what we can do is we can say we can with percent A. The A just means any. I think so. I can say, oh great. So we've got this record here and shows the age, email, and name. So obviously you've got yeah, and these can be, you can obviously you can have a record in here. If I had another record to work with, this could be some other record as well. You can chain them and you can have trees of them as well. So what can we do with a record, right? So say we want to say this name we've given is say the age was wrong, right? So we want to update the age of a record. So how we do that? We could say something like and what the new age here, age equals new age with person. Or maybe it's the other one. Other way around, maybe person. I forgot how this works. So if this works. Then 1, 2, 3, and we put it in A happens here. Oh, it seemed to work. How do I get rid of this warning though? Field labeled when expected. I don't think that error is right. It might just be confused about that. Yeah, that's all it's complaining about. For some reason, I don't know why, but it couldn't determine. Normally, it's smart enough to figure out that age uniquely maps to this type, because it's the only one. It's the only thing that in the namespace. But I suspect there's something going on with the fact that I'm running this in a notebook and it's getting it confused. But if you need to resolve any ambiguities, you can just prefix it with the type of the record to qualify it. So this is how. So I mean, anyway, the thing to notice here is that you can take the existing record in person 1 and just make a change to a field specifically, just like this. So I didn't have to. I didn't have to create a new person and fill in email and name again. I could just specifically change the age that I wanted to, change the field I wanted to change. Yeah. So that's how you can update it. In match statements, sometimes when you're doing processing of a record, you want to do something with the specific field in the record. So say we only wanted to print the age of a person, then we have to use a match statement. So we can say match person with goes like this. How does this work? I think that's right. And then if I just do person with age, is it any longer? Yeah. That gets it out there. And then if I do print age person 2, should get 33. And I do. So this might be looks a bit confusing because it looks like I'm binding person age to value age, but that's not really what's happening. It's just pattern matching here. So what's going on is that it's just extracting the value of person age and putting it into and binding it to this value here. Do you guys see that? Like, it's not the same as this expression here, even though it looks the same, but because the context is different where it's being used. One's a write, and this one here is it's a read operation that's going on. It's reading the value into this. It's reading the value of age and naming it with age here. Um, Another way of doing that is might look a bit weird, but you can say something like this as well. Let's call it the age. Oops. So, oh, I just need the. I think I may not need. I may not need these around. Sometimes with let bindings, it gets a bit tricky. How that works. Okay. Yeah. So like this is the same thing that's going on here is going on here with the at the in the let statement, in the let expression. So here I'm just saying let bind the age to the value of the age of person one. Um, and this is here is it's different from what's going on here, even though it looks kind of similar, and it's different because this is actually happening on the left hand side of the expression. Whoops. Whereas this is these variable assignments or settings are happening on the right hand side on this line here where it says we're set up person one. So both of these cases are examples of pattern matching. So one way to pattern match is via the match statement, but you can also do it in a let binding. Yeah. So that's how you extract a value out of a record. Um, I'm not sure if you can actually. I don't know if it supports F sharp does the dot notation, but in object-oriented programs, you can often say something like person one dot. I don't think it does. Oh, it does. Yeah, you can do that too. No. What? 25% B. Don't to do that. So that's another way of doing it. But that's the way of just dotting into the record and using a dot to get the value that you want. Um, but there are a couple ways of getting that value out with a record. Does anyone have any questions about that? Okay, it's pretty simple. Have you guys used records in Python and R before, or not really?
No.
No? Oh, okay.
Yeah, I don't think so. Unless I just don't remember it being called. I recognize it, but I'm not entirely sure.
They may call them something else, but records are a pretty common term for this sort of thing. It'll probably be in the language in Python and R. You just haven't encountered it. Yeah. Um, Okay, the next one we're going to look at are discriminated unions. You wouldn't have seen these before. It's pretty, not many languages have them. So a discriminated union is something that, let's say we call it fruit, where only the value you can only have one of the value. So it's basically one of these and only one. Let's do that. Yeah, that's good. My fruit equal an apple, and that's how that's so if we have a look at the type of this, the type signature of my fruit, it's of type fruit. So it's important to note that these here, the type is fruit, and these terms here after the bar are called constructors. And they used to construct the type fruit, and then my fruit is bound to that value after the construction. We can extend these and say, like, say they're a string, for example, and we can do something like this. And then if we do that and we do this, the compiler, oh, why did that not complain? Would complain. It's not. It still expects it to. It's yeah. It still expects the string. So we say apple. That's better. So now my fruit's a fruit with a string value apple. And then I can similarly I can say print. I can do a print fruit function. Fruit. The compiler will warn you if it's incomplete, so it knows that fruit's of type fruit, and it knows fruit can be an apple, orange, or pear. Therefore, this match statement is incomplete, and it warns you about that with this warning message saying incomplete pattern matches on this expression, and even tells you what it could be. So it expects a value that an orange could be there, and it's saying that because orange isn't there, that this match expression doesn't cover all the possible cases. So we'll add them in here. Orange. Yeah. Then if I should get apple coming back. So that's basically a discriminated union, or they're called union types, and so it's different from a record because you can only really you choose one of these only. You can't have multiple. It's not a mix of things. It's not a collection of things in the type, whereas a record is a collection. um. So the next one, yep, we'll go on to tuples. Uh, tuples. Have you heard of tuples before in Python? Or it's in Python, I know, probably in R as well. But
I've definitely heard the word. I may even know what it is. I'm just having a hard time recalling exactly what it is.
okay, yeah, okay. So tuple is it's a mixed collection of types as well, like a record, except it's not they're unnamed. So you can't reference them by name. You only reference them by position, essentially.
Okay.
So a tuple is
This is
like
a
some
data science concept, but is it kind of like k nearest neighbor? Like, does it go into that sort of concept?
no, that sounds more like a graph.
It is kind of a graph.
Yeah, no, I'm not.
Is
No, no, it's not. It's not a graph.
yeah.
I mean, sure, a graph can contain a tuple. A node in a graph can contain a tuple. But it's not a graph.
Okay. Gotcha.
Yeah, I'm not probably not gonna. It's more, yeah. I don't think I'll. I don't know. I'll see how it goes. I may not get onto graphs, but if I do, it'll be later in this series. At the moment, I'm just covering like some of the real basic stuff.
Gotcha.
Um, yeah, but I'll try and relate it back to some of the stuff you guys are doing, like in data science and business information systems. But I need your input for that.
Yeah.
I just need to know, sort of, yeah, what you're working on or what you're interested in. You just send me an email or send me a message in Discord, and I can look into that. Um, yeah. So a tuple looks like something like this. You basically use the parentheses. Um, so say I wanted to represent, let's go back to this record, right? And say I wanted to represent age, email, and name again. I could just simply just write it like 22. Email would be clear at email.com, and the name would be clear. So that is a, what did I do? I didn't close the thing. That's basically a tuple, and you can see it's unnamed. So if I do that, I'm making a lot of typos this time. Print print fn. So it's basically unnamed and everything's by position. So if I wanted to, if you, the thing is, you have to know the position, uh, of of the field because it's unnamed. You can't select by name. You have to select by um position. So you have to go something like name. Yeah, name. And then ah, sorry. Call it T. That's the one. So here I'm passing T into this function print name, and I'm pulling out the name. I'm basically binding the value of this person's the value in that third field to this label name, the variable name, and then I'm printing it out. So you can see it's different from a record in the sense that you don't have, it's just not as descriptive. You don't have a descriptive field that tells you what that value is, so you can't just read it and know. You have to sort of know beforehand that this third position is the value you're after. The underscore here is just a shorthand way of saying I don't care. I don't want to bind a name to anything, and that's used throughout in a lot of places in F sharp code. For example, I could use an underscore here as well if because I'm just ignoring the name. I don't use name in this in the subsequent expression, so I can actually replace that with an underscore. If I did that here, the thing would complain because compiler would complain because it's not defined. But in the other expressions, because I'm not using it, it doesn't care. Um, so that's tuples basically. So what's going on in a lot of the .NET functions? So when you use F sharp, you have to interact a lot with .NET. So think of a .NET function. Um, Let's try. I'll just have a quick look up for some on the internet for .NET function that might work for this. Uh, have a look. Actually, client. Alright, I'm just having a look for an easy function to work with that takes tuples as inputs. Let's have a look at. Might work. Let's see what add does. Yeah. I'm just trying to find a function that's like not gonna be too confusing to use. Um, and that's harder to actually find than I thought. Than I thought. done. Yeah. Oh, I'll just make one up here inside this. I'll just make it up here to be honest. So say I wanted to create a function to update the record that I had before. So I wanted to update person. I could do it like this and define. So what I could do is I could specify like this: age, name, and email, and I can say age, name, email, person, and these are the new age. Just so that it's clear. I'm just prefixing it with new. Um, why is this complaining? Oh, sorry. I used thought it was a tuple. So, yeah, it's kind of silly, but if I was to for the name is and email can be um, we don't we don't we don't need this. Yeah, it's just a new person. Yep. That works. What? Did something weird. Did I do that? The display function range. Oh, it's silly. You know how silly this is? This is very silly. Very silly. Is that right? No, that's not right. Why does that not do what I want? Oh, it didn't. You know what? It didn't. It didn't. When I deleted the person, I had a parameter there, person, and I didn't update this part of it. I didn't run this here after I deleted it. So the compiler was using the old definition down here. In this section here, I was using the old definition of update person. So that should be the same as that. Hopefully the same result. Yeah, it does. Yeah, so that's good. Yeah, so in what was I going to show you? In this case, it's a tuple. So whenever you see the brackets, the parentheses, I should say, around parameters like this with the comma, that you read that as a tuple. It's not a. It's actually just one. This is all, as far as the F# compiler goes, this is all just one parameter, and the parameter is a tuple. It's not three parameters that you're passing to update person. In other languages, like C, if you've done C or C++ or Java or C#, these are three distinct parameters that are passed to the function. But F#, it's different. This is one parameter that is a tuple. Do you know what the names of these? When I say parentheses, do you know what that means?
Yes.
Do you know what? Do you know? Do you know? Basically, do you know the difference between parentheses, chevrons, braces, and brackets?
I've never heard of
Yes.
that second one, but everything else I have.
Oh, okay. Okay, so parentheses are. Well, let's go. Parentheses. These are these things.
Right.
Brackets are these. Braces are the curly ones. Chevrons are those things. If they use like the greater than less than signs, right?
Right.
But they're used as they use in F#. This they use not only for greater than less than, they use in other contexts as well as ways to to bracket things essentially. Yeah. So that's the technical. Well, that's the strict technical definition of all those, or terms of the names for all of those symbols. Sometimes you'll see these called as square brackets. Yeah. Pretty sure that's right. Let me just Google that just to make sure I know what I'm talking about. Let's see. Braces. I'm pretty sure. Braces, brackets, parentheses. Yeah, so braces are the curly ones, brackets are the squares, parentheses are your sort of semicircular ones, and chevrons. What is a chevron? Syntax. Let's make sure. Pretty sure I know what I'm doing here. See if we can Google it. Symbol. Chevron symbol on a keyboard. Yeah, the angle brackets are the chevrons. Yeah, basically the greater than less than signs are also called chevrons. Yeah.
Okay, I got you. I've never heard of chevrons before, so
Yeah. Learn something new every day.
yep.
Now you can go and impress your friends and say,
Oh, for sure. Yeah.
Definitely.
if there's one thing if there's one thing you can come away from this with, it's like, oh, I know what a chevron is. They'll be like, man, yeah.
It's
What's the next bit? Where was I? Oh, misc. I'm not really sure what misc is. That's just short for miscellaneous. In case you didn't know, you probably knew that. Oh well. I've gotten. I don't know. Do you have any questions? It's been like 40 minutes, so I feel like 50 minutes is like more or less enough. It's more or less what I want to do. Um, I'll just throw it open to you guys now.
yeah, I don't really have any questions. I'm sure I'd have to go through it one or two more times just to like completely like, grasp
Yeah,
everything.
it's
But
hard. It's
yeah,
hard if you don't have like a practical application to use these things with. And a lot of it's just been like I know this first month has been it's been kind of like just really like
learning.
theoretical, not theoretical. I
Yeah,
don't know how you say it, but it's been just these are the features of the language,
yeah.
but it's been without much context. Um, so that's why I'm relying on you guys to provide some context. I actually do want you to come up with something from your courses and tell me, like, oh, this would be interesting. Let's see how we can investigate this in F sharp.
Yeah.
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 I mean, like you mentioned K neighbors or something like that.
Yeah. K nearest
Yeah.
neighbor.
K
It's
nearest
a
neighbor.
machine learning technique.
Yep. We can do that. You want to
That
see
would be
that? I
cool.
can do
Yeah.
that.
That would be pretty cool.
Yeah. Okay. Well, let's do that then.
All right.
I think I'd find that interesting as well. Um, yeah, and we can go through some K nearest neighbor shit from machine learning. I can find an F sharp library for that, and um, yeah, well, we can solve. We can. I don't know. We can see what comes up.
It's kind of the weakest machine learning thing that I've learned. Like weakest as in like the one I'm not as good at. So it'd be useful to actually go through it, even though it's in another language.
What do you use at the moment?
Well, they taught us a bunch of things. So they taught us how to use decision trees. So like the three types of decision trees. They taught us naive Bayes, and then they taught us k nearest neighbor.
Yeah.
And so
Oh, but what
basically
language I
we
mean are you using at the moment?
Python.
Oh, okay.
Just
Yeah.
Python.
Oh, that's fine. Yeah, I'm not a machine learning data science expert, so if I do demonstrate anything, it'll just be like at a very superficial level. Like I don't really know the algorithms behind that. I mean, I'd have to sit down, have a read through it, and then think about it, and then I'd probably catch on um, to how it works. But yeah, I'm pretty sure, I'm pretty confident I could show you how to do something with F sharp
Mhm.
using one of the machine learning libraries.
That'd be pretty cool.
Yeah, so maybe we can do that next week.
Oh yeah.
But then, yeah, and I think we've probably covered enough of F sharp to do that. There might be some weird like syntax things that you won't know, you wouldn't have seen before. But I think with what we've done, like got these basic types out of the way and functions, it should be enough.
Okay.
Yeah. So yeah, and if you have any like material you want to just send through, just feel free to do so. That would help me actually, so I know what you're looking at and I could make the stuff relevant.
Okay.
Um, yeah,
Try to. I have a data mining course, and I know. I think if I had I don't know if I have the access to the materials from last semester, which I think was more in depth. But we I've been reintroduced to it this semester, but I think it's more basic. I'll try to look at it and see if it goes in depth, but if it doesn't, I'll try to find something else and send it your way.
Okay, yeah, that would be great. Yeah, because that'll give me direction to work it towards. Okay. And Faiza, do you have any questions, or are you okay for the now?
Oh, I'm okay. I just realized that Yojith mentioned decision tree and k-means. I actually did that last semester, so I think uh, that would be good for next week.
Okay. Okay. Oh,
So
I'll look into that then. Oh, okay.
all right.
Well, I don't have anything else to say then. Yeah. Well, thanks for coming on. I'll see you next week, and yeah, remember to send me the information about about your data science stuff.
I'll try to send it by tomorrow morning, so that's
Yeah, I need the time. Like,
12-ish
don't send
hours.
it to me. Don't send it to me next week Sunday, right?
Well,
otherwise,
yes.
otherwise I'll be like, I can't do this. All right. Okay.
Yeah.
Just send me as soon as you can, like tomorrow. Yeah, that'd be great.
Yeah.
Okay. Okay. All right. Bye. Have a good rest of the week or
You as
whatever it is
well.
you've got left of the
Yes.
weekend. Okay. Okay. Bye.
Bye, everybody.
Bye, everyone.